First of all, I would like to thank everyone for dedicating time to join this two parts of series of webinar. And in today's session, what we're going to take a look at is we're going to dedicate some 50 minutes to Python, and we're going to take a look like 15 minutes or 10 minutes of what Python is, what it can do for you, and how different people are using Python around the world to solve different types of challenges related to data they have in oil and gas industry, especially people who work in upstream. So that's going to be the first part. And the majority part of today's session is going to be hands-on practice of what we can build in Python. So I will be showing you things that you can build with just few lines of code. So there will not be involving like any 100 lines of code, like thousands lines of code, like too many code extensive things. No, we will try to create minimal code with maximum impact. So this is what we are trying to achieve today. Now, the thing that you're seeing today is, or well, the thing that you're seeing in front of you, it's an empty application. And it's a template for application that I have emptied out, and we are going to try to fill this out with different analysis. And we can also add lots of things to this. So this is going to be the first example to fill out this. The second example I'm going to show you is how to start reading LAS files and create a well integrity analysis based on the data that comes out from the LAS file. So without further ado, let's go ahead and start the session. We will be starting this session with a few slides, and it's not going to take too much time from us because everything is going to be on the practical side. So let me open up the Okay, so thank you so much for your patience. The screen should be visible, and my voice should be also audible to you guys. And in these 2 days, you're going to see many practical approaches into using Python for oil and gas industry and targeting basically all of these data problems we have. The idea of using Python is not just to flex muscles. The idea of using Python is much more than that. Python is not a hype. Python is not overrated. Actually, it is underrated. Once you go Python, once you understand how different things can be created in Python, which is not that hard, by the way, you are never going to go back to the manual workflow that you usually used to do. And we have actually hundreds upon hundreds of cases with people with success stories with Python and how they transfer their workflows into Python. So first of all, let me tell you who we are. At PA, we are a leading digital learning and training provider company for energy industries. We provide training for almost all the sectors of the energy industry, that is upstream, midstream, and downstream. We have been teaching different parts of data technology and latest technical trainings on oil and gas industry for the past years. Plus, our training is an innovative training. This training materials and training slides are all created by us by taking actual feedbacks from the people who we do training for. Plus, we take special requests or we take personal requests from people who join the training so we can improve our training. So based on the past 4 years, our trainings evolved a lot because we include lots and lots of feedbacks from the people who join our training. One of the important questions that you should ask yourself why you're learning Python. And if I do my job correctly, I should be able to answer this question, or at least you will know what is possible and what is not. So what's there for a petroleum and a reservoir engineer or a production engineer or anyone who is working in subsurface technology? Why do we need Python? Why suddenly Python became the tool of choice for people who want to accomplish more in a little bit or short period of time? So let me show you why. Number one, If you use Python, you can apply innovative concepts, or you can introduce workflows and algorithms to your solutions in the subsurface teams that did not exist before. You can introduce machine learning, you can introduce AI, you can introduce all of types of smart modeling that people charge money for. You can do this for free by just understanding how the tool works and basically applying your domain knowledge. You can take control back by using Python. Back in the 90s, the commercial softwares were booming. So some of the freedom of the users were already taken by these softwares. But now Python is now back. So programming is now back again. And now programming is better than it used to be in the 20 or 30 years past, because now it's easier, it's more powerful, and the best thing, it integrates with the solutions and the workflows that we already have. So if you have, for example, Pipesum, or you use Prospar, or you use Mbal, or you use Reveal, or you use, for example, real-time data that's coming from Pi server or any type of server, the chances are like 99% of the time, Python is integrable into these types of workflows to make the workflow faster and even more smart. Plus, you can save time and human efforts. If you're working with large volumes of data, then the chances are you're wasting a lots of time on copying and pasting. You're wasting lots of time on doing manual work, on monitoring the efficiency, monitoring the operations, monitoring the drilling rigs, and basically writing manual reports. But with Python, it does not have to be this way. In Python, you will come up with a logic, and that's it. You are never going to write that logic again. You will write it one more time, and you will run it thousands of times, not just multiple times, thousands of times, to generate daily reports, hourly reports, monthly reports, anything that you wish to do. These types of things usually are not easily done in other tools like Excel. So Python is to the rescue. Plus, you can integrate Python with digital oil fields, other oil and gas technologies, or other oil and gas softwares that we're going to see in the upcoming slides. One of the most important things that I cannot emphasize enough is what Python is and how it can transfer your abilities. Let's take an example here. So we all know that oil and gas industry, it's not, let's say, it's not the industry it's not the only industry that's providing energy to the world. There are also other parallel industries. So that's why some of the things that we invented in the oil and gas industry are going to be remaining in oil and gas industry once the industry moves on. Why is this? Because these things that we invented, or some of the things that we invented, are so special to the oil and gas industry. So that's why there are no use cases for them in anywhere else in the world. But Python is not like this. Once you learn Python, you learn a tool that is general, applicable to anywhere and to any industry. I know many people who used to be oil and gas engineer, or people who worked with subsurfaces. Actually, they transferred their domain just by knowing Python. They knew Python, they understood what Python is, and then they shifted industries. I know lots of people. I know some people, petroleum engineers, who now are working as programmers. I know petroleum engineers who are now working as data analysts. I know some petroleum engineers who are working as software engineers. The idea is, once you learn Python and spend some time to mature in Python and understand what actually it is about, you can even shift industries by knowing this tool. Take a look at a Python, we can see that Python, it's not a very new tool. It is actually, it's a modern tool, but it is not hyper modern. It was released, the first release was in 1991. So this makes Python newer than Visual Basic, newer than C++, but definitely not the newest language in the market. Python grows so much. People love Python because it's easy. You can do lots of things with minimal code. As of now, as we're speaking, Python is being used basically for everything. And I am not exaggerating. I mean for everything. It's being used in mechanical industries. It's being used for engineering designs. It's used in chemical industry. It's used by NASA. It's used for in nuclear industries. It's used to design nuclear reactors. It's basically used in everything. So here is a small list of what Python is mainly used for nowadays. Number one, you can use Python for web development. You can develop websites. You can develop backends of websites. You can do lots of things with this. For example, some of the codes that run Facebook and Instagram are based on Python to do all of these analytics and route all of these commercials. You can do typical software development with it. And a very infamous case would be Techlog, a software by Schlumberger that's built on Python. You can do mathematics, which is a replacement for MATLAB. And yes, there are lots of academia people who are using Python as a replacement for MATLAB because MATLAB is paid and Python is free. I'm not saying MATLAB is worse than Python or vice versa, but people or some people, they search for or they look for the free version or let's say the cost-effective alternative. You can use Python for system scripting and report automation. You can use Python for data science. And believe it or not, 80% of Python usages nowadays are coming from data science. And unfortunately, data science is not just one thing. Data science, it's an umbrella of many, 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 many things. This includes data analysis, data engineering, machine learning, artificial intelligence, large language models, automation, anything in between. This is considered as a data science. Plus, some people use Python for CFD or computational flow dynamics because it allows to use some free libraries and some powerful calculations as well. Actually, there are lots and lots of use cases of Python, and definitely oil and gas industry is one of these use cases. People love Python for many, many reasons. Here are a few reasons why people love Python. Number one, you don't have to write lots of code because everything is already built for you. Number two, there are large community. It means whenever you are going to face a problem, the community of Python is just too large. Most probably the answer to your problems are right on the internet if you surf it. Plus, it's free. We already said that. It's easy to learn. This is relatively, or this is in relative to other programming languages, it's very easy to learn. Plus, it is easy to share the code. The code that you write on Windows, it's going to run on macOS. It's going to run on Linux. It's going to run on Unix. It's going to run on iOS and Android. So just one code runs on everything, and it is vice versa because the code is universal and there is nothing special about each of these systems. Everything is shared among these. Plus, there are good number of oil and gas libraries in Python that we can use. And today you're going to see 2 or 3 of these libraries. If you think that Python is used to generate only tools from scratch, or you can build your tools from ground up in Python, you have to think this twice because the software providing companies like Schlumberger, like PE Limited, like Paradigm, like Aspen, all of these companies started to provide an interface to Python where their softwares now can talk to Python to do various tasks. For example, you can do some statistics with Python. You can connect Python to these softwares in order to exchange data, to run simulations, to control it, to link it to digital oil fields, and do lots and lots of things. If you stick by tomorrow, I am going to show you a use case of using PETX IPM where we are going to use Prosper and connect that to Python as well. So if you stick that to tomorrow, you will see that as well. Plus, there are lots and lots of libraries that are going to be used for oil and gas industry. For example, we have LAS file readers, DLS file readers. We have libraries that work with fluid properties. We have libraries that are working with with the nodal analysis, we have libraries to visualize well path. We have libraries to do equation of states. We have libraries to visualize pore networks, well networks, rock properties, caliper tool visualization and analysis. We have lots and lots and lots of tools. So Python is basically, it's a big framework that allows you to accomplish many, many things with minimal code. So this is all the theory that you need to know. Now we have some 30 good minutes left for us to do some Python coding. So what I'm going to do now, the first example that we're going to do is we have these lines of code that are written. So the first lines of code is going to get some libraries for us. The second line, it's basically going to show a title for us on the screen. The third line is going to split our application into many tabs that we want, and yes, everything is flexible. So let me show you what this is looking like. So if we put everything side by side, so on the right-hand side, this is the Python application, and on the left-hand side, it's the code that we're writing. So if we write our code successfully, whatever that we're going to write on the left-hand side, it's going to show up on the right-hand side. So are you ready for this journey? Let's go ahead and start this. And just a reminder, minimal code is going to be written, and everything I am going to write, I am going to explain what this does exactly. And most of oil and gas workflows are going to be very similar to what I am going to do in just a few minutes. Okay, so let's go ahead and start. Number one, let's say that we have a particular data set that we want to read and make a tool around that data set to create basically some production analytics. So let me show you the data that we are going to work with today. So this is what the data looks like. And it is a tab separated data. It contains lots of wells. It contains lots of information about any of the wells that we want to work with. So first of all, we are going to read that data. And if you want to read data in Python, you don't have to write everything from scratch because there are already infrastructures for you to use. You only call these functions to read data. So let's call this data equals to Pandas, which is the library that's used for reading data, read underscore CSV, which is our ASCII file reader. So we need to provide the name of the data. In our case, let's copy the path to the data. So let's go copy path. So this will set Python or will tell Python where the file is coming from. So yeah, it's going to be as simple as this. So we will also say that this file is separated with tabs, which is very similar to what we have in Excel. Once you see, or let's say once you read the data, you can also show everything on the screen to the right-hand side. So we will say, for example, we can view data frame. By the way, data frame is just a fancy name for table in Python. In Python, we call a table data frame. Data. So once you do this, just save it and make sure that you refresh also the website. There we go. Now you're also seeing the data. But yeah, seeing the data is not a big accomplishment because, well, this is sort of given. Data is something that you're going to read, but the thing that we can do is we can also search in the data. For example, let's search for crawl. It's not existing. Let's search for my. There we go. It's basically, it will start search for us. For example, let's search for Osprey. Yeah, basically it will start finding lots of things for you if you search in the data, but this is not the idea. The idea is not search for something. The idea is to start creating interactive dashboards around this data. So let me show you how to do this. We will be creating a figure, which is basically a interactive chart, which is way, way better than the charts that you usually generate in Excel. And you will see why in just a second. So we are going to create a line chart. And from this line chart, we will tell it, take all the data on the x-axis, make sure that you show us the time in days or the days elapsed on production. And on the y-axis, you can show anything you want. For example, let's show the gas volume. This is one of the things that you can show, the gas volume. You can also show other charts as well. Let's now move with the gas volume and make sure that we are displaying this on this wells trolley. So because we have two tabs now, the application is splitted in two, the wells tree and the compare wells. Compare wells, we're going to create a tool that compares 2 or 3 wells together. For the tree is basically we're going to display multiple wells. For now, I will be deleting this line. I don't want to see any tables printing out. I want just a clean application. So we're going to do something like this. So the first tab, we're going to display a chart. So it's going to look like this. Make sure that you save this. Now, once you save this, the application is going to refresh. Yeah, so this is what the chart looks like, but the chart is very ugly now. Why is this? Because the chart does not have any context. Usually these types of charts usually should be colored by well. And if you want to color this, you will think that this is extremely hard to do, or this is quite impossible, because usually whenever you do these in Excel, it's very rigid. It's not flexible, but in Python, it's just like 2 words. You will type color equals to lease. That's it. Save it. And now your wells are going to be colored accordingly. And you can double click on any well just to view that well, or you can basically select any number of wells. Maybe you want to compare, maybe you want to see, and you can basically do lots of things with this. You can just hover on this, you can zoom, you can basically do anything you want. This is in regards to displaying everything together. But the thing that you want to do sometimes, it's just to have a single place or a single location or a single chart for each well. Now, if you think that you're going to write down like a very fancy logic in order to split the wells based on the chart, split the data, well, think twice. This is not the case in Python. In Python, everything is laid out to be created simply and beautifully. So we will say that facet columns, it means that we're breaking down our chart by the names of the wells. And the more important than that, the columns are going to be 4 columns for each row. So this is what the wrap means. So each 4 columns we are going to wrap and call it a day and open a new row. Save it and just wait for the results. This is what's showing up. Now, each well has its own row and its own cell, but it's not very understood what's happening here. So let's make sure that the chart is a little bit bigger so you can see what's happening. So for this, we can make sure that the height of the chart is 3000 pixels and make sure that the row spacing or the spacing between them, it's very minimal so we can accommodate for all of these charts at once. There we go. Now these are all the charts that we have generated. If you scroll down, you will see all the charts. And yes, the charts are still interactive. So if you zoom in on any location, everything is going to show up and everything is basically going to be interactively zoomed out. This is one of the greatest and easiest tools, yes, that you can use for production monitoring in Python. It does not have to be gas volume. It can be anything you want. For example, maybe you want to see water volume. That's just fine. Just swap this with water and just watch for the results. By the way, there are also some options that you can allow the user to select whatever columns he or she wants to see. Now, this is for the water as well. So you can do this and you can also see what the water looks like. Now, for this, you can also add trend lines. So basically, you can add a trend line to see the overall trend of the water. Is it increasing or decreasing? In order to activate this, it's very easy. We will say that trend line equals to, for example, OLS. Make sure that you save this. I think, yeah. Let's make sure that this swap to scatter plot. So these are dot plots, and then we're going to have a trend line and save it. Wait for a couple of seconds because now we have more than 50 charts are showing up. So now these are dot charts. You can zoom in, and the best thing that you might not see it yet, but if you zoom in, there is a single straight line that's fitted on top of these charts. And if you try to do this manually, like in Excel or any other like softwares that you usually use, like spreadsheets, this is going to be extremely daunting task to do. not just this. You can do more things from based on this. So let me show you. This is just one of the things that you can achieve. You can click on this PNG or this snapshot button. It's going to save everything for you. So now the picture is downloaded. If you open it up, this is your picture, and you can, of course, share it with anyone you want. You can, by the way, you can, of course, control what the chart also looks like, or how many column it contains, how many well it contains. All of these details are controlled by you. Now let's add one more example. So this is basically viewing everything together. One of the things that we can do is in this tab, we can show all the available leases and all the available wells for the user to select from. So once he or she selects the wells, then we can start to compare them. And once you compare these wells together, you can also create a type curve based on these. Let's create the well comparison first, and then I'm going to show you what a type curve is. So for this, in order to make sure this is working, on the second tab, we are going to say we want to show some selection options. So let's call the selection option wells, and the options are going to come from the data and the column that's going to contain all the well names for us. If you save this, you will see that some options are started to show up. And this is what I have decided to show. There are other components as well. You can show, for example, select boxes. You can show multi-select boxes. For me, I'd love to see this pills. This is called pills, by the way. You can also activate the multi-selection mode where you can select multiple wells at the same time. So if you say selection mode equals to multi, now suddenly you are selecting multiple wells at the same time, just like this. Let's move on. Now, once you select the wells, you will take whatever the user is inserting into these wells and start to display those as well. So for the sake of simplicity, I'm not going to write down like the full plotting logic one more time because we already have some plotting action that we're doing on the top. So I'm going to copy that and paste it. But first, we need to generate a new table based on the selections. So in order to do that, believe it or not, it's very easy to do. So let's call this selection equals to original data. We will say that filter down the data based on the lease and based on whatever the user is selecting is in the wells or within the wells that are selected. We will copy the chart just like this and then paste it. Let's call this figure 1. And let's swap this to line one more time. Let's swap this to line. And there are lots of things that are redundant now. Let's delete all of these. We don't need these anymore because we have only few wells are selected. And we're going to show this on the second tab by showing the chart, passing the chart to the application, saving it, and just wait for everything to update. Yeah, now let's make sure that this is selection. Save it. There we go. Now you're only seeing few wells. You can select any number of wells you want, or you can take out like any number of wells. Now I'm just selecting 3. You can select, for example, 6 wells or 7 wells, or you can select 2 wells. You can select like any number of wells you want. So the important part is there is now an ability to select any number of wells you want for analysis. Not just this, you can also swap the y-axis to accommodate the log or the log scale, because the log scale will allow you to see all of these wells with different scales. So once you do this, now you can actually start by thinking about creating a type curve. A type curve is just an average curve for all of these wells. Let me show you how this is possible, or let me show you how we can create a type curve. By the way, if you want to do this like in Excel, it's going to be a very daunting task to do. Let's take out the Huron and like take out the duck from the selection. So we will be leaving out with type with wells that are very close together in terms of production. So basically they are very, very close together. If you want, you can add like other wells that are similar to these. Yeah, you can add like any number of wells that are extremely similar in performance. So this is the key idea. Now, let's start creating our type curve. So by the way, if you think that creating a type curve in Python, it's hard, actually it is not hard to do. The only thing that you need to know of, or the only thing that you need to understand, is how these type curves are created. And the way the type curves are created is basically by averaging out all of these wells. By the way, if you want to do some data processing as well, maybe so you want to replace all of these empty data that does not exist, maybe you want to carry over the data, maybe you want to fill back the data. All of these are possible, by the way. You can also smooth out the data as well. I am going to create a very simple type curve without any data processing. So this is going to be a very raw type curve, but it can be improved a lot if you spend a little bit more time on it. So let's create the type curve. So in order to create the type curve, what we are going to do is we are going to take the data selection that we had and make sure that we are only getting the time in days, and we're also getting the gas underscore volume. And what we are doing is, based on these two columns, we are going to group by everything by the time, because once you group everything by time, now you can do different statistics. For example, you can calculate the average over time, you can calculate the cumulative over time, you can calculate anything you want. For the type curves, usually it's the average over time. So let's group by the time in days. So the time in days is going to be the key for us to group by. So let's call this type curve data. So we can also show the type curve data, by the way. Let me show you what the data looks like once you have everything grouped out. So type dot write. Let's write this to the screen. Type curve data, save it. And yep, let's do a mean. Let's do an average of everything because we want the average across the wells. You can, by the way, you can also show the cumulative across the wells. That's also a possibility. Save it. There we go. Now you can see the average actually across all of these dates. And you have a single date and then the average gas volume from all of these selected wells. And yes, the key thing is if you select another well added to the stack of the type curve, now you're going to get a different sets of data. So because this is a very interactive type curve thing, let's add this to the original chart. Simply within a single line, we'll say that figure 1 dot add traces. By the way, a trace is just another line added. So we will go a line, and then on the x-axis, we're going to have the type curve index, and which is the time, by the way. And the y-axis, we're going to set the type curve or the type curve data for the gas volume. So gas volume. And make sure that you save this before you proceed. So y equals to this. Save this before you proceed. And now you have a new curve added, which is this one, the trace 5, but the name is not correct. So let's change the name first. We can give this a name of type curve, and make sure that you also give this a very nice color to distinguish it from other wells. So color equals to yellow. So save it. Now you have your type curve looking like this. And we can also say that the average, or I think, yeah, it's good now. Yep, this is good. Let's click. There we go. One thing that you might want to do is some of the let's say some of the locations of this type curve, it's not very smooth. It's very abrupt. What you can do is you can also create a rolling average or moving average on top of this. So by saying rolling of, let's say, 20 windows or 20 data points at a time, and then add the average to this. Save it. Now the type curve is going to be much, much, much more smoother than before. Now this is what your type curve looks like. So if you want to emphasize on the type curve, just you want to emphasize on the type curve, actually you can make everything, for example, transparent to emphasize on the type curve, by the way. Let's, for example, do something like this. Figure 1 dot update traces and make sure that the opacity or the transparency is equaling to like 30%. Once you save this, now you can see that all the charts are non-transparent, or it's slightly transparent, and the type curve is actually the dominating chart. This is for the gas volume. If you want to do, you can also create a type curve for the water volume as well. So let me show you. Yep, actually, let's copy these. Everything, water volume in everywhere. There we go. Now this is your water type curve as well. So you have created a single water type curve. And you can also analyze this. It's not just about creating this type curve. You can also export the type curve into Excel. So let me show you. We can say type curve dot to Excel. We can save this in type curve.xlsx, and believe it or not, that's it. Once you run this, or once it runs itself, now your data is already there for you. So let me show you. This is the data, type curve.xlsx. If you open that up, you will see the time that's grouped, and this is the water volume that's grouped. So if you select these two things, now it's going to show you the same plot in Excel, but it is way, way more uglier than what you have in Python. So yeah, please stick to Python for these types of analysis. This is a very, 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 let's say, flexible charting. For example, you can select like any selection of wells or any number of wells, for example, to be more precise. It says that the Excel is open, so we need to close it because now it's trying to update the Excel. So let's try to select more wells. By the way, you can have like any data set. Any data sets that's included alongside with this data set can also work, by the way. So we can zoom in and you can see what your type curve looks like. You can also maximize this chart by clicking on the screen, and yeah, this is what you're going to get. You're going to get a type curve across many, many, many wells. So this is the second example. The final and the third example that we are going to see, it's in terms of analyzing the multi-finger caliper tools. So before we start on this, usually in oil and gas wells, uh, as the well produces, the integrity of the metal, or let's say the integrity of the well itself, will get compromised. It can get compromised because of the corrosion, and sometimes the accessibility to the well itself becomes very, very limited. Why is this? Because you are going to get some deposition inside these wells. Now, guess what usually people do? Usually people will run these types of tools. It's either magnetic tool, which is called MTT. It's a magnetic tool that runs into the well, or you can use a mechanical tool, which is called MFC. So do you see all of these feelers and all of these mechanical fingers? So these will rub against the tubular. So basically, you know where you have some defects or where you have some deposition. Now, what's the problem with this? The problem with this, the data that you usually get, it's what you have. The softwares are really expensive. There are no free softwares that you can use. The data that you can get, it's extremely hard to visualize. And that's why we over at PEA, actually, we created a library just for this, and the library is already online. So I will show you how we can use the library that we have created in order to visualize all of these heat maps and finger tools. Okay, so let's start by using the library first. So let's open up the second example for the MFC. So the first thing that we are going to do is we're importing this library that we have created, which is called tubular integrity. And the second thing that we are going to do is we are going to import a library called Lasio. Lasio is a library that allows us to read LAS files. So this is the key part. So if you don't have like a way to read LAS files, it's going to be extremely hard. That's why interpreting well logs in Excel, it's extremely daunting, but in Python, it's heaven. So let's read the last file. So las equals to lasio.read. So we're going to read our file. So the file, let's get the full file path to our last file, which is a caliper tool file. Let's make sure that we are pasting the path. And then once we paste the path, make sure that you convert this directly into a table. Once you convert this into a table, run it. This is what you see. This file contains 52,000 depth points and 105 columns. We have too many columns to select from in order to start this. And the beauty about this library that we created is that it's very flexible. You can select any number of tools you want or any number of channel readings you want. So let me show you, because each finger and each pad on these tools will generate a single column. So a column in these, it's equivalent to one of these fingers. So we need to be smart about this. So I'm going to write a logic that goes through these. So I will create all of these mechanical calipers and all of these magnetic calipers. These are going to be empty containers. Once I find these in the table, I will add it to all of these containers. So we will say for column in last file columns, and then we will check if the pad, or let's say if this is magnetic, or if it's containing magnetic padding in the column itself, it means that this is magnetic. So we will add it to the magnetic part. One more time, we will say if it is finger, or basically it is mechanical in column, then mechanical caliper tool, append the column. Once you do this, once you run this, you can see the columns you have. For example, we can say las of only magnetic part. It will only show you the magnetic part of it, which is actually 12 columns alongside with the depth. If you want to see the mechanical part of it, or the MFC, it's actually 24 columns alongside with the depth. Now, do you see now you have two different sets of data? And actually, I didn't tell you why these tools are used in conjunction. So the mechanical tool can only see the inner diameter of the current tubular, while the magnetic tool can see beyond that. So it's outside of that, because it's magnetic, it depends on the magnetic field. So you are actually targeting two tubulars at the same time, but it's quite expensive to purchase these types of software. So that's why we generated a Python library for this. So let me show you how we can simply visualize this, and you will be amazed how simple it is. We will start first by the magnetic tool. So let's do create a magnetic tool analysis. So let me show you. So tubular integrity dot create, or let's say plots well integrity. And inside the well integrity, this function that we developed, it requires two things: the last file, and then what things you want to see. For example, we want to see the magnetic thicknesses. And if we run this, believe it or not, that's it. That's all you need to know. By the way, we can also suppress the warnings, because sometimes Python generates warnings. So we can say warnings.filter warnings, just to make sure that we ignore all of these warnings, because we don't want to see warnings taking up some space. There we go. This is what the tool looks like. You can also pass in the coloring. For example, we can color it as none, no color templates applied. So you will see actually a white chart. And this chart is also interactive. You can interact with this. You can hover on top of this. And believe it or not, this tool is free. It's not paid. So you can zoom on any portion of this. Every spike is basically something wrong with the tubular, or this is the tool joint. Okay, so you can also zoom in to just one tubular like this. So you can analyze this a little bit better. So this is the two-dimensional window for the magnetic tool. Actually, we can copy this and then we can generate another response, or we can generate another chart, but this time is going to be for the mechanical part, which is for the inner tubing. We can run this. This will generate another chart for you, but this is going to be a different response because this is seeing different tubulars. And of course, the thing that you're seeing on top, this is the casing because it's the outside. And the thing that you're seeing below, it's actually the tubing. We can, of course, zoom in. That's also a possibility. By the way, the chart is still interactive. So you can see all of these fingers. You can hover on top of it. There are some statistics for you. Plus, you have the two-dimensional map as well. If you're not satisfied seeing this, you can also convert this into a two-dimensional or three-dimensional plot. Let me show you how you can do this. The same code that we wrote, we can take it and convert this into a two-dimensional or three-dimensional plot. So this is the same code, but we're going to do a three-dimensional window using the MTT, or we can do the M or the caliper or the MFC. We can use anything, any one of these we want. We will run the file, wait for the window to show up. There we go. This is the interactive window. Of course, you can interact with this. By the way, it's very, very smooth, by the way. So because it's an external window, one thing that you can do, if you want to exaggerate the length, you can actually crank up the length. So the tubular become much, much more longer. And some of the things that are going to be easier to see, some of the things are going to be harder to see. It's totally up to you what you're trying to do. So this is regarding this. You can also increase the radial scale. So in order to make the pipe a little bit more puffy, or let's say it's you make it a little bit fatter if you want, if I may say that. So this is what the tubular looks like. It's not just about this window. There is also another window that we developed that basically you can pass in your data, like the minimum caliper or the minimum ID. For example, the minimum ID is, let's make sure that we swap the window to plot 3D boundary window. So this will show you the plot alongside with the ID boundary and the outside diameter boundary. So if we run this, it will take the inner diameter and outer diameter, and it will plot two boundaries for us. So the blue boundary is the outer boundary of the chart. We can actually turn both on and off. We can turn on this again. So anything that's not protruding out of this blue window or blue boundary, it means your pipe is not penetrated. Now, do you see this? The pipe is not penetrated because it's clean. But if you activate the other filter for the inner diameter, so these are actually the corrosion patches. So some of the patches are corroded, some of them are just okay. And you can also do the same window for the casing as well. Just swap the caliper with the casing, run this, and wait for the window to show up. There we go. Now this is the outer casing, and you can see the outer casing actually it requires some attention. So the inside diameter is actually 6.36 because this is a 7-inch liner and 7-inch from the outside diameter. So if you run this, this is what we are going to see. So the blue shell, it's your outer diameter, and you see some penetration. So all of these rings that you see, these are the tool joints, which is understood because we did not take it into account. But anything else than these tool joints, for example, these spikes, this means there might be some puncture, or let's say there might be some problem with our tool integrity. So we can turn these off, and we can also see some corrosion patches and some deposition patches as well. So yeah, this is how you can use these tools for analysis. Of course, you can also drive some analytics as well from the fingers. So let me show you. because you're already generating these fingers. What you can do is for the thickness tool or the magnetic thickness tool, you can also create an average. So you can say that mean across the rows. So it will show you a single mean value across the depth. So this is the mean value for this depth. This is the mean value for this depth. And you can also swap this for the maximum, for example. You can also show the maximum value per depth. You can show the minimum value per depth. You can show the standard deviation per depth. You can show all of these things and much, much more by just using these simple lines of code. This is all I have from my side for today. Please make sure to join in tomorrow's session to see more interactive and more, let's say, more advanced workflows in Python for upstream and subsurface domains. Thank you so much, and over to you, Nikhil.